Ladies and gentlemen, boys and girls, children of all ages. Today I'm going to work two adding fractions problems that have different denominators. Maybe two. I don't know. Maybe you'll annoy me and I'll only do one. Or maybe you'll annoy me and I'll do 91. Who knows? The first problem, we're going to add 1/3 and 1/4. Either one of my Eli's, can I add them the way they're written?
No.
Why not?
Because they don't have the same denominator.
They don't have the same denominator. So you've learned using fraction pieces. We have 1/3 and 1/4. So we've learned how to do it using fraction pieces, where we got to find the exact same size of the same fraction that'll fit below here. Okay, we always set it up with 1 because that tells us whether our sum is going to be less than or greater than 1. And is it going to be less than or greater than 1? Less than. Because my sum is going to be whatever this equals, and this is less than 1. Okay, so now we're going to change them so that they have the same denominator. To do that, we have to find the least common multiple for the two denominators we have, 3 and 4. And I'm just going to list the multiples of 3 and the multiples of 4 until I find the first one that shows up in both. Now, if you have a multiplication chart, then you're awesome, because then all you have to do is look at the row that starts with 3 and the row that starts with 4. And so we'll go 3, 6, 9, 12, 4, 8, 12. Oh, bam, look. 12 is my least common denominator. So I have to change these so that they're both over 12. But I can't change the value. So now I know I'm going to use my 12ths over here. And that 1/3, it appears, is going to equal 4/12. Well, how do I know, without using fraction strips, or without using the fraction strips online, how to make this into 12ths? Because what if I don't have a fraction strip for like 7/35? I don't have a 35ths fraction strip, so I have to know how to do it mathematically as well. Luke.
So you on the denominator, you have to figure out how many times it goes into the denominator.
Awesome. So I have to figure out what I do to 3 to get to 12. Now, when I'm finding equivalent fractions, I can either multiply or divide. I can't add or subtract. So going from 3 to 12, it's getting bigger. So that means I'm going to multiply 3 times what is 12?
4.
4. And whatever I do to the denominator, I must also do to the numerator, and so that does equal 4/12. Now I have my 12, so I can check out and see how many 12ths 1/4 is. And then I can verify 1/4 looks like it's 3/12. I can verify that by doing the actual mathematical stuff. And as Luke told me, I need to see how many times 4 goes into 12. So 4 times what is 12? 3. If I multiply the denominator by 3, I must also multiply the numerator by 3. And 1 times 3 is? 3. And when I add fractions, I always go back and look at the sign, because I've done a lot of work here and I don't want to forget what the sign is. Because if your teacher, who's a jerk sometimes, gives you some addition, some subtraction, and you forget what the sign is, and then I'll have to laugh at you. I mean, I wouldn't laugh at you for that. That would be me. I'm just saying. And so 4/12 plus 3/12 is 7/12. We can check it looking here at our model. 1, 2, 3, 4, 5, 6, 7/12. So the model works, and the actual mathematical stuff works. So now let's look at one other problem. That other problem is going to be 1/8 plus 1/2. Now you see a lot of people write it sideways. For me, it's easier to do my equivalent fractions when I do it, write it like this. But let me ask Emily Kate, can I add these two fractions the way they are? No, I can't. Why not, Emily Kate? They don't have the same denominator, so we cannot do that. So, Emily Kate, is my answer going to be less than or greater than 1? Less than. Because this is my sum, and this is the 1, so it's this much less than. That much less than 1. Now I've got to go and I've got to find a common denominator. Well, the more you do it, the easier it's going to be. If I look at my multiplication chart, and I can look and I can do my 2's and 8's. 4, 6, 8. Now I knew it was going to be 8, so that's because I'm 112 years old and I've probably done this exact problem 27,000 times. Or at least these two denominators that many thousand times. So I know it's going to be 8. Now I have to change this so that it's something over 8. I have to change this so that it's something over 8. Now 1/8 is already has 8 as a denominator. So 1/8 is going to stay 1/8. I don't have to change it. It already has that denominator. I just need to change the denominator 1/2 to something over 8. And if I get my 8 pieces out, my 8th pieces out,
We don't have any.
yeah, you do. You just have them electronically on the interweb that you can use. Oh, and it looks like, by my calculation, that 1/2 equals 4/8. But I need to check that and make sure it's mathematically correct. So I have to ask Whit, what do I multiply by 2 to get 8, Whit?
4.
4. Thank you, Whit. And whatever I do to my denominator, I must also do to my numerator. So this is also multiplied by 4. And 1 times 4 is 4. I go back and I check the sign. The sign says it's an addition problem. Since it's an addition problem, I add the numerators. Denominators, I don't change. Once I have them the same, we're all good. Stays over 8, and that gives me 5/8. Now, I can't simplify those. You already know how to simplify, but I can't simplify those. Neither one of those could be simplified. All right, and we can check. Well, we have 4/8 plus the 1/8, so it does indeed equal 5/8. God bless, love you, do something good today. Save the peace. Please subscribe, share with your friends.